Alright guys, so this is the homework problems that we talked about in the email that you have to do. Before you watch these problems, make sure you watch the first video on vectors posted. It should be right underneath this video. So go ahead and read the problem and pause the video, and then do the and then after you're done you can restart the video and watch the work being done. Alright, so now that you got a chance to do the problem, let's go over the answer. So Superman is flying at 15 miles per hour at an angle of 24 degrees from the wind. So we have to make a vector for Superman and make a vector for the wind, and they are at about a 24 degree angle. So that's 24 degrees. And we'll say that this one is Superman. He is flying at 15 miles per hour. And this one is the wind at 24 miles an hour. So I'm going to go ahead and make this one a little bit bigger. Right. So now in order to solve how many miles per hour Superman's flying, we're going to use the parallelogram method. And I'm going to go ahead and make my parallelogram, which would be something like this and this. And then I'm going to draw my resultant. But before I draw my resultant, I know that I'm going to have to find the angle right here. So this angle right here is going to be the supplement of 24. So the supplement of 24 is going to be 156. So this is 156. I'm going to go ahead and draw my resultant. And I'm going to go ahead and take that triangle that I just drew and kind of put it out here so I can work with it a little better. That's the 156. This obviously is the resultant, which I don't know. This is the 15 because it's a parallelogram, and this is the 24. So in order to find out what x is, which would be how fast Superman's flying, I'm going to go ahead and use the law of cosines. So I'm going to say x squared equals 24 squared plus 15 squared. So I'm going to do that now in the calculator. You get 801 minus 2 times 24 times 15, which is 720, times cosine 156. So I'm going to go ahead and, since everything's on this side, my variable is isolated pretty much on the left side, I'm going to do simplify the right side of the equation. And you get about that, and then when you take the square root, you get x is about 38 19/100ths. So that's how fast Superman is flying. Then next I wanted to know at what angle compared to the wind. So the wind was right here. This was the wind, so this line represents the wind. So, and this is the new where he's flying. So I'm looking for this angle right here, which turns out to be right here. So now that I have that 38.19, I'm going to use the law of sines. Sine 156 over what we just received, which was 38.19, about, is equal to sine x, and is right across the 15. I'm going to say sine theta 15. So after I'm done cross multiplying, you end up with 15 sine 156, kind of ran out of room. And you're going to divide that by 38.19. And that equals sine theta. So theta is going to be inverse sine this whole problem. So let me go ahead and work that out. So you get about 9 degrees. Alright, now we're going to try the next one. Go ahead and pause the video and then, try it, and then we're going to go through afterwards. Alright, now let's go through the answer. Alright, so this is the picture that you should have should have drawn from the information. I'm going to make a parallelogram and then draw my resultant. So since this part was 20, the other angle, this is supplementary, so that's going to be right here, which would be 160 degrees. And now, I know since this is 13, this is 13. So to find this angle, I'm going to use the law of cosines, and I'm going to set that up now. All right. When you're done working out the problem, here is what you would start off with, and you end up getting x is about 39.47. So that is how fast the boat is going to be going. And then it says its angle in relation to its original course. It originally was going to be going right here. So what I'm looking for now is this angle right there. So to find that angle, I'm going to use the law of sines. So when you, right here I did the law of sines to get that angle, and you get about 6.47.